We are Group 7 of B Division. The group members are roll number 36 Keur Balde, roll number 37 Rutika Bari, roll number 38 Mansi Barse, roll number 39 Shreya Varsude, myself roll number 40 Ovi Bartake, and roll number 41 Shreya Barve. We are going to tell what is a motherboard, what is CPU, RAM, what are internal headers of the motherboard, how does power delivery work in a motherboard, GPU, storage, a motherboard chipset, and input output motherboard.
Hi everyone, my name is Shreya Barve and my roll number is 41. My topic is power delivery in a motherboard. Now we will understand what is VRM and its use. The full form of VRM is voltage regulator module. We know that computer components depend on electricity, but each one of them has different power consumption requirements. Now, how does a motherboard handle it? The answer is VRM. VRM is one of the most crucial parts of our motherboard as it controls power and proper delivery. Due to many electrical components are connected to our motherboard, each one of them has different voltage and electrical power requirements. So, the VRM makes sure that our processor, graphics card, and other components get proper and accurate power delivery at a steady voltage. In general, VRMs are used to control the voltage in our motherboard's components and to keep it as low as possible. VRMs are also required for steady and proper and accurate power supply. Every motherboard comes with a circuit near the CPU socket, and they are what we refer to as VRMs. Now, the second important component in power delivery is CPU power connectors. The main function of CPU power connectors is to connect power supplying unit PSU to CPU. They are typically found near the top of the motherboard towards the left side. Every PC power supply has special connectors that attach to the motherboard, giving power to the system processor, memory, etc. If these power connectors are not attached properly, it would have a devastating effect on our PC. The power connectors are a crucial part. There are different types of power connectors, but two of the most commonly used power connectors are 8-pin power connector and 4-pin power connector. The main difference between the two power connectors is a 8-pin power connector can deliver up to 384 watts of power, which is twice as much as a 4-pin power connector can deliver. This means that the 8-pin power connector can support more powerful CPUs and provide more stability and performance. However, all the motherboards do not come with an 8-pin socket. Therefore, in that types, 4-pin sockets or power connectors are used. The last and important part of the power delivery components is 24-pin ATX connector. The 24-pin ATX connector is that connector that supplies electricity to a computer system components. The 24-pin ATX style connector supplies electricity to the motherboard and other parts of the computer system. As a component of their advanced technology extended ATX, which is the full form of ATX, motherboard specification, it was created by Intel in 1995. The industry standard power supply to motherboard main connector is the Molex or the ATX style connector. It was first used in the ATX form or any for any other ATX based variation. The colors for these wires on the ATX connector are based on their variations. The ATX standard, however, they are not required for compliance to the specification, so they could vary from manufacturer to manufacturer. So these were the three components that are the most important components that are listed from the power delivery. Thank you.
So the CPU. The CPU is also called the central processing unit, and it is one of the most critical parts of the computer that performs most of the processing and calculation needed to run programs and applications. The CPU is mounted onto the motherboard using a specific socket which varies depending upon the type of CPU or the CPU model that is being used. So this is how a CPU looks like inside the motherboard. Next is LGA and PGA. So LGA is LAN grid array socket and PGA is pin grid array socket. LGA are easier for installation and are more forgiving if a mistake is made during the installation. PGA tend to be more delicate and require more care during installation. The choice between LGA and PGA socket comes down to the CPU that is being used and the preference of the user. So this is how an LGA socket looks like, and this is how a PGA socket looks like. And these two are the types of CPU sockets that are used. Next is the RAM. RAM is also known as the random access memory, and the motherboard has slots where RAM modules can be installed. The number of RAM slots varies depending on the motherboard model, but most have at least two RAM slots. So, types of RAM, there are several types of RAM, including DDR3, DDR4, and DDR5. The type of RAM that can be used is dependent on the motherboard chipset and the CPU being used. And this is how a DDR5 RAM looks like, and this is how RAM looks like in the motherboard. So RAM slots are the physical slots onto the motherboard where you can install the random access memory modules, having, for example, having two RAM slots and each slot having a um, maximum capacity of 16 GB. Then the total RAM that you can install on your system would be 32 GB. That's how the RAM slots work. This is how RAM slots look on the motherboard. There are four RAM slots as you can see here on this motherboard. CPU cooler mount. It is a mechanism that secures the CPU cooler onto the CPU, and the mount can be varied depending upon the CPU model. And the CPU bracket, it is a metallic frame which is attached uh, bis- to the back of the motherboard to provide the support to the CPU cooler mount. And this is how a CPU cooler mount looks like. Thank you.
So PCI stands for Peripheral Component Interconnect Express. It is a high-speed serial interface standard used for connecting expansion cards. PCI slots are physical connectors on a motherboard that provide interface for PCI devices to connect and communicate with computers, CPU and memory. This is what PCI slots looks like. The top PCI slot generally is in high-end motherboard made out of metal, so it gives support for heavy expansion cards such as high-end graphic cards. PCI slots come in different versions. Like the latest one is PCI 5.0. It has the most highest speed. PCI slots are used for high performance devices. So graphic cards, sound cards, network cards. These are generally used in PCI interface. It is because it provides high speed communication between the device and the CPU. This is what an M.2 PCI slot looks like. We can connect M.2 form factor SSDs to this. The next is SATA. So SATA interface stands for Serial Advanced Technology Attachment. It is a standard interface used for connecting storage devices such as hard disks and SSDs. SATA connectors are physical connectors that provide the interface for SATA devices to communicate with the computer's motherboard. The left one here is a SATA data cable. It is used to transmit data between the device and the motherboard. The right one is a SATA power cable, which is used to power the storage devices such as hard drives or SSDs. SATA connectors are typically used for storage devices that require slower data transfer rates. So it is much slower than PCIe devices. SATA connectors come in different versions, each offering different data transfer rates. So the latest one is SATA 3.0, which has a highest bandwidth of 6 Gbps. SATA is much slower than PCIe, as the latest PCIe 4.0 and 5.0 can go upwards of 40 gigabits per second.
Internal headers. First is front panel connectors. These headers provide connections for the power button, reset button, power LED, and HDD LED on the front panel of the computer case. The power button header is typically labeled PWR underscore BTN, and the reset button header is typically labeled reset underscore BTN. The power LED header is labeled PWR underscore LED, and the HDD LED header is labeled HDD underscore LED. These connectors allow the user to turn on and reset the computer and indicate when the computer is powered on or accessing the hard drive. Second is fan headers. These headers provide connections for the cooling fans in the computer case. The number and type of fan headers will vary depending on the motherboard model, but most motherboards will have at least one or two headers for connecting case fans. These headers are typically labeled SYS underscore fan or CHA underscore fan and may have multiple pins for controlling the speed of the fan. Third is the RGB headers. These headers provide connections for the RGB lighting strips or RGB fans. They are used to control the color and lighting effects of the RGB components in the computer case. The headers are labeled RGB underscore header or LED underscore header and usually have multiple pins for controlling the lighting effects. USB headers. These headers provide additional USB ports for connecting USB devices to the motherboard. They are labeled USB underscore header and usually have multiple pins for each USB port. Fifth is the audio header. These headers provide connections for the front panel audio jacks on the computer case. They are labeled HD underscore audio and allow the user to connect headphones or speakers to the front of the case. Sixth is the serial ATA or SATA headers. These headers provide connections for the SATA ports on the motherboard. They are labeled SATA underscore header and are used for connecting hard drives, solid state drives, and optical drives to the motherboard. Seventh is the power header. These headers provide additional power connections for the motherboard and other components. They are labeled ATX underscore power or EPS underscore power and are used to connect the power supply to the motherboard. Overall, these internal headers on a motherboard provide important connections for various devices and peripherals in a computer, allowing for efficient and effective operation. Thank you.
Motherboard chipset is a crucial component that serves as the communication hub for all other components of the computer system. It is responsible for controlling input and output operation, managing data transfer between the CPU and other peripherals, and facilitating the exchange of information between the different parts of the system. The chipset is comprised of two main parts, the North Bridge and South Bridge. The North Bridge handles the high-speed communication between CPU, RAM, and graphic card, while the South Bridge manages the slower communication between CPU and other peripherals such as hard drive, USB port, and network adapter. One of the key features of the chipset is to control the peripheral component interconnect or express bus, which is used to connect high-speed devices such as graphic card, solid-state drives, and network adapter to the motherboard. The chipset determines the number and speed of PCIe lanes that are available to the system. The chipset also controls the serial ATA SATA port, which are used to connect storage devices such as hard drives and solid-state drives. The number of SATA port available on the motherboard is determined by the chipset. In addition, the chipset contains the CMOS battery, which is complementary metal oxide semiconductor, which provide power to the motherboard's BIOS and store important system configuration setting. Without the CMOS battery, the system would not be able to retain its setting between power cycles. Overall, this chipset plays a critical role in the operation of computer system, managing the flow of data between various components and ensuring that everything works together seamlessly.
Our next topic is input and output. A connection point that acts as an interface between the computer and external devices like mouse, printer, modem, etc. is called port. Ports are of two types. First is the internal port and second is the external port. So internal port, it connects the motherboard to internal devices like hard disk drive, CD drive, internal modem, etc. Second is the external port. It connects the motherboard to external devices like modem, mouse, printer, flash drives, etc. Then we have the serial ports. Serial ports transmit data sequential one bit at a time, so they need only one wire to transmit 8 bits. However, it also makes them slower. Serial ports are usually 9 pin or 25 pin male connectors. They are also known as COM communication ports or RS323C ports. Then we have the parallel port. Parallel ports can send or receive 8 bits or 1 byte at a time. Parallel ports come in form of 25 pin female pins and are used to connect printer, scanner, external hard drive, etc. Then we have the USB port. USB stands for Universal Serial Bus. It is the industry standard for short distance digital data connection. USB port is a standardization port to connect a variety of devices like printer, camera, keyboard, speaker, etc. Next is the PS2 port. PS2 stands for Personal System. It is a female 6-pin port that standard that connects to a male mini DIN cable. PS2 was introduced by IBM to connect mouse and keyboard to personal computers. This port is now mostly obsolete, though some systems compatible with IBM may have this port. Next is the infrared port. Infrared port is a port that enables wireless exchange of data within a radius of 10 meter. Two devices that have infrared ports are placed facing each other so that beams of infrared lights can be used to share data. Next is the firewall port. Firewire is Apple Computer's interface standard for enabling high-speed communication using serial bus. It is also called IEEE 1394 and used mostly for audio and video devices like digital camcorders. Next is the Bluetooth port. Bluetooth is a telecommunications specification that facilitates wireless connection between phones, computers, and other digital devices over short range wireless connection. Bluetooth port enables synchronization between Bluetooth enabled devices. There are two types of Bluetooth ports. First is the incoming and next is the outgoing. Incoming receive connection from Bluetooth devices and outgoing request connection to other Bluetooth devices. These were the main ports which are the input and output. Thank you.